Beneath these peaceful Manitoba prairies, a monster lurks. 80 million years ago, the heart of North America was underwater. This creature swam the depths. What is this ancient beast? What else lived in the seaway? Finding the answers will take us on an adventure in prehistory.
Hi, I'm Anita Janczyk.
And I'm Joseph Hatcher.
And we're paleontologists here at the Canadian Fossil Discovery Centre.
Today we're going to take a prehistoric journey to the late Cretaceous period.
The late Cretaceous period, a tropical world where dinosaurs roamed the land and giant reptiles called mosasaurs ruled the seas.
Imagine going back in time 80 million years ago. North America had the western interior seaway spanning over it from the Arctic Ocean to the Gulf of Mexico.
Today, all that is left of the great inland sea is dirt and rock beneath the prairies. But 80 million years ago, it was a subtropical paradise, thriving with life. There were birds, sharks, giant squid,
500-pound fish,
even turtles the size of cars.
Fossil hunting's fun to do. You can find some fossils too. Do the dig and find. Do the dig and find. Do the dig and find.
Bentonite is an absorbent clay formed from volcanic ash, and fossils are commonly found in this mineral. Mining for bentonite is common since it can be found in every continent on Earth.
There's a mineral called bentonite formed from volcanic ash, and it can be found in your household products. So remember, the next time you're brushing your teeth, you're actually using 80 million-year-old volcanic ash. Look, it really is everywhere.
Back in the 1970s, while quarrying for the mineral bentonite, people began to discover large numbers of fossils.
I had uncovered something and I thought, what in the world is a fence post doing down here? And it happened to be the jawbone of the mosasaur.
Like there was a whole flipper of some kind of an animal lying there in the ground, and we went to this farmer's barn there, and he had a pail, and we put all the pieces on his floor of his barn there, and we had a whole skull. We had to find out what it was. Yeah.
The unusual discoveries brought scientific detectives to town.
We learn more about life by studying dead things.
In paleo, we incorporate comparative anatomy, biomechanics, geology, climatology, biogeography, and evolution.
It would take about 2 years to uncover and nearly 20 years to assemble this massive 40-foot long puzzle, since nearly all of his bones were found. They named the mosasaur Bruce.
Why do we give them common names?
We give them common names so the general public can relate to them.
It also gives them character and helps connect them to the modern world. It's more difficult for people to identify with fossils when they are called by their scientific names or specimen numbers.
Creatures of an altered time, learn from these bones of mine. Where I have been, you soon may be, the last of your community. Ice caps melt and oceans freeze. What's dry land now may turn to seas. You live like me with little fear, but your kind too may disappear.
Fossil hunting's fun to do. You can find some fossils too. Do the dig and find. Do the dig and find. Do the dig and find.
Welcome to the Fossil Collection Room. This is where we keep our vast collection of fossils from the western interior seaway. Despite what many people think, a fossil is not an old car, a parent, or even your teacher.
A fossil is defined as the remains of an animal or plant found preserved in layers of rock. Joseph demonstrates how fossils are formed.
What happens is a dinosaur or a marine reptile might suddenly die.
A flooding riverbank buries the beast before decay sets in. Then when it rains, the bone content is replaced by minerals in the soil.
And to demonstrate fossilization, I've laid out lima beans.
The lima beans represent bone before it gets fossilized. The popcorn kernels represent fossilized bone.
The original bone continues to be replaced by minerals in the soil until after many, many, many thousands of years, we now have a completely different fossilized bone.
Millions of years will pass until a paleontologist finds the fossil.
This is when we begin to excavate, and on a good day, discover a fossilized skeleton.
But better than a bone, there is now an imprint of a creature that lived in a different time.
And that is how we get fossils.
Dawn of the dinosaurs.
Not in the fact that these are baby teeth by comparison.
Oh yeah, the size alone.
To the size.
Yeah, the size alone.
But you wouldn't know that unless you...
Paleontologists are like time travelers. Even though they are digging here in the present, they see a world millions of years ago, where just around the corner, a giant mosasaur could be lurking.
When we look at fossil ages, we're really meaning geological time. And geological time is broken up into ages, eras, and periods. The museum collection is specific to the late Cretaceous period, which is 80 to 83 million years ago. Is that quite estimates?
I'm not sure. I think it's probably Platycarpus.
You get that time capsule thing. You get everything that was in its environment at the time. And what better time capsule sort of story could you have than an extinct animal swimming in an extinct sea that you can tell what it had for dinner?
Anita spends hours studying the stomach contents of fossils she collects. She's learning how these Cretaceous creatures adapted to their marine environment and how they interacted with each other.
We really don't know what their physical appearance was. I would love to see skin impressions with these marine organisms. Did they have scales, or was it more of a scaly textured skin? And complete the picture.
The fossils also inform us about the prehistoric climate, shedding light on the dramatic changes that have transformed the region into the prairie of today.
We can know how to find out information about the temperature of the seawater.
The Western Interior Seaway was a shallow tropical ocean. The fossil collection at the Canadian Fossil Discovery Centre is a window into the past. It lets us see what life was like in the lush Cretaceous period.
At the end of the Cretaceous period, there was a mass extinction. So dinosaurs and marine reptiles didn't make it past. What happened? What was going on that they didn't survive?
Scientists have put forth many theories to explain the cause of mass extinction. Extreme climate change? A supervolcano? Or even the impact of an asteroid? No one theory has been proven, but together, these possibilities remind us how suddenly and drastically our world could change.
What is the difference between human time and prehistoric time? Is there any?
They're not even measurable on the same scale. These specimens are tens of millions of years old. They provide insight into the world from long ago, as well as where we're heading into the future. These animals are truly a part of all of humanity's fossil heritage.
So we should take great pride in preserving them so they're around for future generations.
Do the dig and find. and find.
Joseph, some people ask me why I study fossils.
Well, it's really cool because it gives us an insight into our ancient past, and it tells us a lot about our world today.
By learning about prehistoric times, we can see how past organisms adapted to their environments and identify key factors for our survival.
To me, the fascination is that, especially when you're digging, and this is the most exciting part, is that you're finding new things that no one has ever seen before. You're the first person to see them.
Looks like a finger bone of a plesiosaur.
With the guidance of these expert paleontologists, groups participate in digs, hunting for ancient marine reptiles. On the floor of the prehistoric seaway, new discoveries are certain.
When we step out into the field for the first time, the fossils aren't just there to be found. We need to look for them, and that's where patience and persistence pays off.
It may take a trained eye to spot a fossil half buried in a layer of shell, but the best place to learn to see them is here in the museum itself.
We're ready to make the next big discovery.
Are you?
He's doing the fossil rock. Swing your arms around the clock. Everybody's doing the fossil rock. Swing your arms around the clock. Cretaceous. Everybody's doing the fossil rock. Swing your arms around the clock. Triassic. Everybody's doing the fossil rock. Swing your arms around the clock. Jurassic. Everybody